Bismillahirrahmanirrahim. Show that for all complex numbers z1, z2 modulus equals to z1 modulus into z2 modulus. For this, let z1 equals to a plus b iota and z2 equals to c plus d iota. Now first of all we will find the product of z1, z2. z1, z2 a plus b iota into c plus d iota. Now we get ac plus ad iota bc iota plus bd iota square. Further we can write it as ac iota square minus 1 into plus minus bd, and take iota common from these two, so we can write bc plus ad iota. Now take modulus z1 z2 modulus ac minus bd plus bc plus ad iota modulus. Now what is modulus? Take the real part square ac minus bd square plus take the imaginary part square bc plus ad square and take the square root. This is modulus. Now expand this one. We can write it as ac square plus bd square minus 2 acbd, and here bc square plus ad square and plus 2 acbd. This whole is under the root. This cancel with this. We get ac square plus bd square plus bc square plus ad square under the root. Equation 1. Now take the right hand side. For this we will find first z1 absolute, which equals to a square plus b square under the root, and z2 absolute, which equals to c square plus d square under the root. I write it directly or you can write it like this, that z1 absolute equals to a plus b iota absolute and then a square plus b square under the root. Similarly this one. Now we will find the product of z1 modulus or absolute z2 modulus equals to a square plus b square under the root into c square plus d square under the root. Now multiply these two, so we can write it as a square plus b square into c square plus d square whole under the root. Now a square into c square, so a square c square plus a square d square b square c square plus b square d square whole under the root. Now we can write it as ac whole square and write this bd whole square. Now bc whole square plus ad whole square under the root. Equation 2. So from 1 and 2, look, this is 1 and this is 2, both are the same. From 1 and 2 we can write it as z1 z2 absolute equals to z1 absolute into z2 absolute. Proved. Part 2. z1 by z2 whole absolute equal to z1 absolute by z2 absolute. So first of all we will find z1 divided by z2. A plus b iota divided by c plus d iota. Okay. So multiply and divide by the conjugate of c plus d iota. A plus b iota into c minus d iota. Here c plus d iota, c minus d iota. Now multiply these two, we get AC minus AD iota and plus BC iota and minus BD iota square divided by C square minus D iota square. Iota square value is minus 1, so minus into minus plus, so we can write AC plus BD and here BC minus AD and take the iota common, and here in the denominator we get C square minus D square iota square. Iota square value is minus 1, so minus into minus plus, so AC plus BD plus BC minus AD iota divided by C square plus D square. This is Z1 divided by Z2. Now take the absolute or modulus. Z1 by Z2 whole modulus equals to AC plus BD divided by C square plus D square. I write it separately as BC minus AD iota divided by C square plus D square whole absolute. Now take the square of this and square root. So AC plus BD square divided by C square plus D square whole square, and this BC minus AD square divided by C square plus D square whole square under the root. We know the absolute. When we expand the absolute, the square of the real part plus the square of the imaginary part without iota and under the root. Or we can take the LCM as this C square plus D square whole square, and now expand these two and cancel the term which can be cancelled. So we can write it as AC square plus BD square plus 2ABCD, and this is BC square plus AD square or minus 2ABCD. These two cancel with each other, so we get AC square plus BD square plus BC square plus AD square divided by C square plus D square whole square whole under the root. This is equation 1. Now Z1 absolute or Z1 modulus equal to A plus B iota modulus, which equals to A square plus B square under root, and Z2 modulus equal to C plus D iota modulus equal to C square plus D square under root. Now Z1 by Z2 modulus, Z1 modulus divided by Z2 modulus, A square root of A square plus B square divided by square root of C square plus D square. So now multiply and divide it with A square plus B square under the root, C square plus D square under the root with C square plus D square under the root, C square plus D square under the root. Divide and multiply by this. So here we get a square plus b square into c square plus d square whole under the root, and this c square plus d square into c square plus d square whole under the root. So multiply these two, a square c square plus a square d square plus b square c square plus b square d square, which we further, and c square plus d square whole square under the root, and this one also under the root. Now we can write it as a square c square as ac whole square. Similarly, b square d square is bd whole square, and b square c square is bc whole square, and a square d square is ad whole square under the root divided by c square plus d square whole square. We will take these two in a single under root. This is equation 2. Now compare 1 and 2. Look, this is 1, a square ac whole square plus bd whole square plus cd whole square plus ad whole square by this, and look at this, from 1 and 2 we have proved that z1 divided by z2 whole modulus equals to z1 modulus divided by z2 modulus. Proved. From 1 and 2 we have proved that z1 by z2 whole modulus equal to z1 modulus by z2 modulus. Subscribe the channel and search on daily basis the videos if I upload it, so follow it, because our course is so lengthy, so we will have to do it on daily basis. If I have uploaded the video, so follow it on daily basis. Thanks.